What's up to all my fellow boaters? Welcome to Technicians Tuesday. It's been quite an interesting day here today. There was a lot to get done. We had a shift issue on a lower unit, and then we had a communication issue on a 2019 39-foot CV with quad Mercury Verado 400Rs. We'll get right into the action with this 2006 225 horsepower Mercury Optimax on a 25-foot Mako. The starboard engine was not shifting into gear, so we started out by checking the digital throttle and shift system, simply by removing the cowling and shifting the engine into gear. Seeing that the shift actuator shifted properly, we pulled the boat out of the water and checked the gear lube. We found a little bit of metal in the black gear lube, but nothing that was out of control, like a gray sludge or a ton of metal or anything like that. I'll put a link in the description to our video on gear lube colors if you'd like some more information on that. But after checking the gear lube, we pulled the lower unit and checked the shifting system to make sure it was spinning the shift shaft where the lower unit hooks up to it. Seeing that it spins, it was time to tear into the gear case. Had to drill out the bearing carrier spanner nut to get it out. 13-year-old gear cases that have lived in saltwater their whole life usually don't like to come apart. But we got the nut out and then had to really put some serious force into removing the bearing carrier. This thing was really stuck inside the housing. With the bearing carrier out, we found some metal on the reverse gear bearing, but the spacer for the gear was lodged into the housing. It looks like the reverse gear failed and allowed enough play in the spacer to let it grind itself into the case. Needless to say, this engine needs a new lower unit. Which brings us to what you came for, that 39-foot CV with the quad 400R Verados. This is a beautiful boat, but it's having some communication issues. You can probably see with all of the rigging in here that this isn't your easy tighten the grounds and the problems fixed type of deal. Before we get going wild here, we need to talk a little bit about how a CAN network operates. This isn't an in-depth tutorial, it is just going to be a quick explanation, and please bear with me because I can't draw. But starting out, you have your engine here, your helm, which has a CCM, and then if you wanted, another helm with another CCM. On this engine, you have a terminator resistor. And this is 120 ohms of resistance. There'll be two of them, one with a blue cap, one with a yellow or red cap. They come off like this for your engine harness, and that connects to your 14-pin data cable. This will come in and come to your control module harness, which will have two more terminators on it. Both of these will be blue and 120 ohms. Now, whenever this computer talks to this, it goes along this network here like this. And these terminators tell it where the end is. So, if you wanted to add another helm, you put this Y harness in here that's a 14 pin. Run another data cable. And connect it to another control module harness. That will have terminators on it. Now, whenever you do this, you need to take these terminators out, because what these terminators do is they tell the network where the end of it is. So as long as this has a terminator, it basically says, well, this is the end of the network where this computer can talk to this one and vice versa, back and forth. So if you wanted to add two engines, you're going to have the same thing with a terminator comes over to your 14 pin another CCM down here on helm 1, then come over here to helm 2 with another CCM. A Y cable comes down, terminator, connects to the CCM. 14 pin Y harness, another 14 pin comes over, control module harness with a terminator and a terminator. So you have your second network here for your second engine. Now, just like this one, we need to take these terminators down here off so that way the network knows where the end is. Now, there are two different networks. This is why we have two terminators. What we want to do, since there is the two terminators, basically the way that works is one terminator for one CAN network, another terminator for another CAN network. So there's CAN 1 and CAN 2, or well, they call them CAN P and CAN H now. But CAN 1 and CAN 2. 2 is all of your helm stuff for each engine. CAN 1 is the entire boat. So for CAN 1, whenever we connect these two engines together, we're going to need to take out this terminator on either the engine or the helm and connect these two, which connects the network. So now it has a terminator here. It can run up to this CCM here in helm 1, no terminator, so it can then come up here to helm 2 where there's no terminator. It'll jump over to here where there's no terminator and then come down to the first helm, down to the engine where the network ends. So these end the network. Now, if we wanted to add another engine in here, you basically just do the same thing. Where we've got an engine with our two terminators, comes up here, we've taken these terminators out, come up to the second station, they're one terminator for the CAN 2, and then you've jumped over to here, and then came all the way back to this engine where you've got two terminators. So in order to extend this, we need to take this terminator out and run another jumper over to here and take that terminator out, and then it can run all the way up to this other harness here, or this helm 2, and that will give you your terminator to terminate it. And then if you wanted to add another engine, same thing, take terminator out, jump it over, run all the way to your engine. And that is basically your CAN network. So, now that we have a little understanding of how the network operates, we can start troubleshooting it. The most important thing to remember is that 120 ohms. That is an important number. In order to find a communication problem in the network, we have to start from the beginning of the network where that terminator is, and then run through the system watching that 120 ohm reading. We start at the engine and unplug the 14-pin harness. Remember, this is a resistance-only test, so the key switches and the batteries need to be off. Taking our meter, we check for the 120 ohms between the F and G pins for CAN 1 or CAN P for propulsion, then J and K for CAN 2 or CAN H for helm. F and G are going to be white and blue, and K and L are yellow and brown. It is extremely important that you do not stick the meter leads into any of the pin sockets on any of these items. You can damage the sockets and cause more harm than what you are already trying to troubleshoot. Also, for the sake of time, I won't really get into the resistances of the PCMs, which stands for propulsion control modules, or the CCMs, or command modules, which go up in the helm. We started at the engines and just went from one right to the next, checking the terminator resistance across the network, as well as the resistance in the PCMs. Then moving into the lower station, I disconnected the upstairs from the equation by simply unplugging the 14-pin harnesses going upstairs from the Y harnesses, and then checked the CCM's resistances and the rest of the network looking for that 120 ohm resistor. With the upper station still disconnected, I plugged the computer in and tested out the system. With everything on, we didn't have any problems. Everything downstairs tested out and was working as it should, telling us that our problem was upstairs. So I went upstairs and tested the CCM resistances and looked for the 120 ohm resistances as well. Then using the computer, I plugged in each engine 14-pin harness one at a time, making sure it didn't affect the system when it was plugged in. Long story short, the two inside engines which run on what is called shadow mode, which just means that they mimic the outside engine's throttle, would mess up the system when they were plugged in. Changed out the resistor packs and then only the port inside engine gave us a problem. Put in a new CCM for that engine upstairs, reconfigured the boat, and just like that, this boat was ready to be tested. And that is exactly how we troubleshoot a communication code on a quad engine, dual station, Mercury Verado setup. I hope you enjoyed watching us troubleshoot this setup and that you learned a little bit about how these systems operate. We've got another great video coming out next week with the brand new Mercury V8 engines, so you are going to want to get subscribed to the channel and get that bell on so you don't miss out. Then let us know what you thought of the process for troubleshooting a CAN network in the comments section below. We hope you'll give the video a thumbs up, and don't forget, you can always reach out to us on our website at bornagainboating.com. Enjoy your Tuesday night, and we'll see you next week.